Since we already learned about exponential functions and logarithmic functions, now we're going to go on to different properties that logarithmics have. So we're going to go ahead and get started with a little review, just so we can remember how to use our calculator in order to find logarithmic values, right? So for example, on this one, we have evaluate the logarithm to 4 decimal places, which is going to be a nice review on rounding. Like I mentioned on the previous video, if you have a feature in your calculator where you could put this in, and it's called the log base feature, you can actually just put this in and you're done. But if you don't, we went over a different way to rewrite this. So in order to rewrite this in your calculator, we write it as a fraction. So remember, you have a log on the numerator, you have a log on the denominator. I'm so sorry about that little g, but you get it. And then the numerator takes the big number. So I'm going to have 0.43 on the numerator. And then in the denominator, you write your base, which in this case was a 4. So I have a log of 4 here. And then you just put that straight in your calculator. So I'm going to have log of 0.43, of course, close parentheses, divided by log of 4. Press enter, and there you go. Now here's the thing, just to practice, when you have an answer being rounded to 4 decimal places, I come here and I count 1, 2, 3, 4. I chop it off here. And then this number tells you what's going to happen to this number. Okay, if the number here is 5 or greater, the number next to it jumps 1 up. If this number would have been 4 or less, then the 7 would have stayed a 7. But since it's a 9, the 7 rounds up to an 8. So that's why my final answer is negative 0.6088. Okay, so be very careful with those, because I'm pretty sure maybe you might do the whole thing right, but then you're off by a decimal because of the rounding. So just make sure you double check your work. Okay, so let's go ahead and try one more. Evaluate the logarithm to 4 decimal places. I threw this one in here because I thought you might get scared with the square root of 7, but it's okay. Sorry, this is the 7th root, but it's the same thing we've been doing. Now, here's a trick, right? Remember that when you don't have a base here, it's an invisible 10. Just as a reminder, you don't need it though, because your calculator does have a log button just by itself. So in order to put this in my calculator, I'm going to go ahead and press log, which is right here. Now, in order to do the 7th root, you have to be very careful. The way to use or to put a 7th root or an 11th root in general, right, any kind of root, you have to put this first. This is what we call the index. So I'm going to have to press 7. And now to put a square root or a root, you cannot use the square root. So don't think you could use this one here, because that one's a square root. What you're going to have to do is go to the math button, which is right here. And you're going to have to use this one right here. This is the one you're going to use when you have any type of root that is not a square root. Pretty much that's not a square root. So if you want a cube root or a 4th root or a 21st root, you have to use this one here. Okay, so again, let me just do that again real quick. We did the log, and then we put the 7. You always have to put the index first, so I put a 7. And then I went to the math button and looked for this one right here, number 5. That one tells you what kind of root you want. And then after that, I press that button, this shows up. And then you just put whatever's inside the root, which in this case was a 10, close parentheses, press enter, and that's your answer. Now, since it's 4 decimal places, I count 1, 2, 3, 4. I chop off the answer here. Since this is a 5, it's going to make the 8 round up to a 9. So my final answer is 0.1429. All right, so again, that was just meant as a review. Later with the logarithmic buttons, because I know they're pretty new to us, but that's all you would do. Now, here comes the good stuff. This section is about properties of logarithms. Logarithms are very important. They're very neat because they come with a really special property. So let's go ahead and, there's 4 properties. We're going to go ahead and start with the first one. Whenever you have 2 logs, and this is very important, make sure you look at this. Whenever you have 2 logs that have exactly the same base, you can only do this with logs that have the same base, and they're being added, you could kind of squish them together, which I really like. So if you have 2 logs with the same base, you're just going to write the log once. And since they were being added, whatever was inside the logs is now going to go together, and now they're going to multiply. Okay, So this is a very nice property because we can start kind of doing shortcuts. Instead of having multiple logs, we could just squish them into one. But just remember, when they're being added, they multiply. So look at this. You no longer have two logs. Now you have a 1, but whatever was inside the parentheses now is together in one parenthesis. And this could also work vice versa. If for some reason you have only one log and whatever is here is being multiplied, if you want to rewrite it as two logs, you could also go that way. Okay, so just so you know, it's going to be at your convenience. Now, there's a second property. If you have two logs that have the same base, but they're being subtracted, what you're going to do is that you're going to have the same log, and I'm so sorry about this. Go ahead and fix this here. It's going to look like this. Okay, so if you have two logs with the same base, but they're being subtracted, you're going to squish them into one log. You no longer have two. But inside the parentheses, you're now going to have a division. The first log is going to go on the numerator, and the second log is going to go in the denominator. So pretty much this is the rule. When you're adding, you're going to multiply, and when you're subtracting, you're going to divide. Okay, again, don't worry if you don't understand this. We're going to have a couple of examples to practice. Now, the two remaining properties that we have is what we call the exponent property of logarithms. This one's pretty cool and pretty easy. Whenever you have something in front of a log, you can cut it and paste it as an exponent at the very end. So if you notice, the p disappeared from the front and now it goes in the back as an exponent. And again, it could be vice versa. If you don't want the p as an exponent, you could just move it to the front, and that's where it comes from. Okay, so again, this only works when you have a logarithm. So don't start moving exponents to the front just for fun. Only if you have a log are you allowed to move whatever's in the front to the back or whatever's in the back to the front. And then this one, we did talk about it very slightly in the last video. This one's also a fun one. Whenever you have ln of e, they just cancel each other out and you're just left with the 1. Okay, so ln and e. It does not work when you have log e. It has to be an ln, which is the natural logarithm we already talked about in the previous lesson. So ln e cancels out. We're just left with 1. Okay, so again, make sure you have all of these properties in your notes. Again, I understand if you don't quite get them yet, because again, we just talked about them right now, but in the few examples right now, you're going to start seeing how they come in handy. So let's go ahead and do this example here. They're asking us to simplify into a single logarithm. So as soon as you see this problem, you notice that there's two logs, but they're asking us to simplify into one single log, which we can do because we already learned the properties. Now, in order to see if we can use the properties, remember they have to be logs with the same base. So let's go ahead and look at this one. This one doesn't have a base, so it's an invisible 10. This one doesn't have a base either, so it's an invisible 10. Since they have the same base, we can combine them into a single logarithm. Now, you cannot combine them yet because both of these logs have a number in the front. But if you remember from the properties, whenever you have something in the front, you could just throw it to the back of that log. Same thing here. Now, when you move it to the back, remember it becomes an exponent. If you have, oh my goodness, what is she talking about? Let me go back. Remember this property? Whenever you have something in the front, it goes to the back, but as an exponent. So that's what we're going to do. So I'm going to have log 3 to the second power because the 2 goes to the back. And then on this one, I'm going to have log x to the fourth power. Now, I'm not done yet because they asked me to combine it into a single logarithm. I still have 2. Now, I'm going to ask myself, what's happening between these two? They're being added. So according to the property that we talked about earlier, when you have two logs that are being added, I can simply put them together in one log, but whatever was in here, which is these two, now have to be multiplied. So instead of having 2 logs, I now have 1. And then whatever was next to the logs now go together, but multiplying. I don't have to put a little multiplication sign because obviously when two things are next to each other, they're multiplying. But that's how we did it. So I don't think it was that terrible. All you have to know though is your properties. So again, when you have a number in the front, throw it to the back as an exponent. And since these two logs were adding, I just multiply them together. But again, it's very important that you see that we no longer have 2 logs. We only have 1. All right, let's go ahead and try a few more. This one's actually even more fun because we start with a single log and they're asking you to expand it. So they want you to write as many logs as possible. So we have a log base b, and then let's go ahead and analyze what we have here. We have an exponent, so I know what you're tempted to do right now. That exponent has to come to the front. But be very careful. Since the 7 is only with the m, I cannot move it to the front yet. What we have to do first is separate the x and the m. Since they're next to each other means multiplication. So according to the property, if those two are multiplying, that means that they used to be two different logs that we're adding. So that's what I'm going to do. I'm going to separate them. So since multiplication according to the rule means addition, I put a plus sign, and each x in each variable takes their own log. Now be very careful. This log is the one that has to go with each one. So if you notice, it's still a log base b. Log base b of x, log base b of m to the 7, and since they were multiplying, it becomes an addition problem. And we're not done yet because now I can finally move that 7. Remember, when you have an exponent, it goes to the front, not all the way to the front of the problem, only to the front of its own log. So this would be my final answer. Log base b of x plus 7 log base b of m. And that's what they mean by expand. You start with one logarithm and you end up with 2 or more. But in this case, it was only 2 because I cannot separate anything else. There was only 2 variables, so the x took one, the m took one, and that was pretty much it. All right, one last one before we move on to the last part. Simplify into a single logarithm. Again, we have 2 logs. First thing we do is look at the base. This one has a base 4. That one has a base 4, so that means that yes, I could combine them together. Now, before I do anything though, there's a number in front of the log. So obviously, hopefully we could all agree that that goes as an exponent. Oh my goodness, that was meant to be an arrow. So there we go. The first one, I don't touch it. There's no number in the front, so that one stays like that. Log base 4x, and then the 3 becomes an exponent. Now, I don't have any other exponents to do. Now I have to do is just somehow combine both of these. So look at the symbol in the middle. Since this is a subtraction according to the properties we learned earlier, this can now be rewritten as a division problem. Now, I'm no longer going to have 2 logs. I'm only going to have 1. This is going to be my numerator, which is x, and now this whole thing is going to be my denominator. And that's it. We finished the problem, right? They wanted a single logarithm. We only have 1. So that would be my final answer for this one. All right. The last thing we're going to do in this video is learn how to solve equations using logarithmics. So what we're going to do is we're going to use the properties we just learned because believe it or not, that's what they were invented for, to help us solve equations. So this is what we're going to do. Whenever you have an equation where you cannot have the same base on both sides. So in the previous video, in the previous lesson we learned, we were able to modify the equation, manipulate it in order to have the same base on both sides of the equation. But that's not always going to be the case. There's going to be some problems where as hard as you try, you cannot have the same base. So that's why logarithms become your best friends, because they're going to help you solve the equation. So again, all you could do is just apply a logarithm to both sides and it's going to be very helpful. And again, I know you're like, what is she talking about? Don't worry. Here comes an example. So here we go. Such an innocent problem. It looks super tiny. And in the last video I showed you, all you have to do is just make the same base. But as hard as you try, there's no way you can have the same base on this problem because you cannot write 8 as 5 to a power of something. There's no way. And there's no way you could write 5 as 8 to the power of something. So that's how you know that you're going to have to use logarithms. So don't freak out, but this is what you're going to do. You are going to apply a log to each side of the equation. Okay, I know it looks like I'm making the problem worse, but it's going to be very helpful. So whenever you have something like this where you just cannot make the bases the same, you're going to apply a log to the left side, but of course what you do to one side, you do it to the other. So all you have to do is just put the word log in front of both of them. Now, we are experts on the properties already. When you have a log, the exponent can go to the front. So look at that. We were able to drop down the x to the front. So x comes here. I still have log of 5. And on this side, I still have log of 8. Now look at that. We're almost done. Since I have to solve for x, how do I leave the x by itself? Don't panic with this. This right here is seriously just a number. You could just put that in your calculator. It's going to be a number, but we're not going to figure it out yet. All I want you to do is, how are you going to leave the x by itself? If two things are next to each other, it means that they're multiplying. So in order to leave the x by itself, don't panic. All I have to do is just divide by log of 5. And I know you're like, why is she dividing by letters now? Remember, it's not a letter, it's an actual number. Like if you put in your calculator log of 5, it's going to be a number. But I don't want you to do that because we have to find the answer first. So if I divide both sides by log of 5, this cancels out. And look at that, I'm done with the problem. On the right side, I'm left with a fraction, which is log of 8 divided by log of 5. And on the left side, I'm left with x. This right here, before you put it in your calculator, is what we call the exact answer. If on any assignment or homework I ask you for the exact answer, this is what I want to see. Now, if I ask you to approximate it, then you just put this in your calculator and this would be your approximation, the decimal. Again, to put this in your calculator, just put log of 8 divided by log of 5 and voila, you're going to get that. So again, I want you to see the difference. Exact answer means whatever you get from the problem. Approximation is whatever you get from the calculator. Okay, so make sure you see the difference between those two. All right, again, we only have a few more examples to do, so let's go ahead and try the next one. Again, when you have a problem like this one, first thing you want to do is see if you can have the same base on both sides. Again, I'm just going to save you the headache. There's no way. There's no way you can write the 9 with a base of 2. 2 to the something is never going to give you 9. So again, that's a dead giveaway of knowing that we are going to have to use logs. So I'm going to go ahead and apply a log to the left side, and I'm going to have to apply a log to the right side. Remember, whatever you do to one side, you do it to the other. Now, what this allows you to do, it allows you to move the exponent to the front. Now, I'm quickly going to go back to the last example. Here, when I move the x to the front, I just moved it to the front, that's it. But on this one, since I have two things on the exponent, when I move it to the front, I have to put it in parentheses. Okay, so make sure you make a note of that. So let me go ahead and erase this real quick. And the exponent goes to the front, so I'm going to have x minus 2, and then the log of 2 is still there, equals log of 9. So I didn't do anything to the right side, I just moved the exponent to the front on the left side. Now again, your whole idea is to leave the x by itself. So this parentheses is multiplying with the log of 2. Remember, when two things are next to each other, they're multiplying. So in order to leave this parentheses by itself, I'm going to divide both sides by log of 2. And I know it looks so crazy because you're dividing by letters, but it's okay. We're going to divide both sides by log of 2. So give me a minute while I write that down. We're going to divide by log of 2 on this side. And look what's going to happen. These are going to cancel out. But what I do to one side, I do it to the other. So I divide also this side by log of 2. Now, please don't think like, oh my goodness, the logs cancel out. There's no such thing. We're going to have log of 9 divided by log of 2. And then on this side, I'm just going to be left with x minus 2. Now, this does look crazy, but don't worry. All you have to do is just solve for x. So the only thing I have to do now in order to solve for x is move this 2 to the other side. Now, if I move it to the other side, I'm so sorry, that's an arrow. If I move it to the other side, it's going to become a plus 2. And look at that. That's it. I'm done. X equals log 9 over log 2 plus 2. And again, this is your exact answer. So this is your final answer. If I ask you for an approximation, you just put this in your calculator. Just make sure you put it straight the way it is here. Log of 9 divided by log of 2 plus 2, and this would be my answer as an approximation. All right, we only have 2 more to go. E to the 5x equals 10. Again, same thing. There's no way you can have the same base, so we have to add log to both sides. Now, here's the tip. Whenever you have, I'm not going to write it down, but make sure you put it on your notes. Whenever you have an E, do not use log. Okay, don't get me wrong, you can. If you want to use log, go for it. But we're going to use ln instead. Because one of the properties we talked about earlier is that when you have an ln and an e, they cancel out. So that's why we're going to use an ln. So again, make a note of it. Whenever you have an e, we're going to add ln instead Of course, when we do to one side, we have to do it to the other side. So I'm going to add the ln here as well. Okay, so I'm going to add ln to the left side, add ln to the right side. But look how cool this is. Whenever you have an ln, boom, those cancel out. So I'm just left with 5x equals, of course, the ln didn't cancel out on the right side, so it's still there. Okay, so look at that. On the two last problems, we used log, but on this one, since we see an e, we have to use ln. So those cancel out. I'm just left with this, and we're pretty much all done because in order to leave the x by itself, since it's being multiplied, I'm going to divide both sides by 5. And that's it. There we go. My answer is x equals ln of 10 divided by 5. That's my exact answer. Again, if I ask you for approximation, just put it in your calculator, and I got 0.4605. Of course, already rounded. So just make sure you know the difference. Again, if you forgot, exact answer, what you get from the problem, approximation, what you get from the calculator. Okay, you guys made it to the end. This is the last problem for today. Again, dead giveaway, there's no way we can write the 9 with a base of 4. So that means, hey, we're going to have to use the log. Just so you know, you can also use ln. You can add ln to both sides. Feel free. Again, if you want to use log, you could use log. So I'm going to go ahead and use log because that's what I've been using throughout the whole video. But if you want to use ln, trust me, you're going to get the same answer. Just remember, if you add ln to one side, you have to add ln to the other side. Don't go all crazy and put a log here and an ln here. Whatever you do to one side, it has to be exactly the same on the other side. So I went ahead and put log on both sides. Again, the whole idea of adding a log is so that I can move the exponent to the front. So that gives me 5x log 4 equals log 9. And the only reason I wanted to include this problem in here is because if you notice, the 5 is being multiplied with the x, and so is the log 4. So if you want to leave the x by itself, you have permission to divide by both things you want to cancel out. So I'm going to divide by 5 log 4. But of course, if I do it to that side, I have to come and do it to this side as well. So I'm going to have 5 log 4. On this side, the 5 and the log 4 cancel out, leaving me with just x. And then on this side, again, don't worry. I know it looks super scary, but that's it. That's your answer. Log 9 divided by 5 log 4. And just again, as a reminder, that's your exact answer. If you want an approximation, just put it in your calculator. And it gave me 0.317. Okay, so if I lost you again, I know this is might be a very confusing section, but please go back, watch the video again if there's something you didn't understand. You're more than welcome to come to class so we can review together, or just simply send me an email.